Right, so here we're going to have a look at the absolute value of numbers, or the modulus, what's called the modulus of numbers. So it's written like this, two straight lines like this, two vertical lines. So you may remember from geometry that if we have 2 points, A and B, and we want to find the distance between A and B, we would write it like this, the distance between A and B. Now in terms of numbers, if we have, say, the number 3, the absolute value of 3 means the positive value of 3. Well, the positive value of the number 3 is just going to be 3. It's already positive, if you like. But if we have the positive value of minus 3, the absolute, we put these two vertical lines on either side of minus 3, well, the positive value of minus 3 is going to be 3. So all you've got to do is get the positive value of whatever is in between these two vertical lines. So in terms of the number line, then it's just the distance from 0. So if we go here, minus 1, minus 2, minus 3, minus 4, the distance from the origin, or the 0 here being 3, would be that distance there. Or you have another one out here down to minus 3 as well. So for example, if we have the modulus of x is equal to 3, what could x be? Well, x, as we've seen here, could be minus 3, or x could be plus 3, because if I put a 3 in here instead of x, well, the modulus of 3 is 3, as we've seen here. If I put a minus 3 in here instead of x, I'll also get 3. So x can be two different values here. X could be minus 3, or x could be plus 3. So that's how you would solve a very simple modulus type equation. So the modulus of x is equal to 5. Well, then x could be 5. So if we put a 5 in here instead of x, well, the modulus of 5 is just 5, so that's fine. Or x could be minus 5. So if we put a minus 5 in here instead of x, well, the modulus of minus 5 is 5, so that works as well. Both of these work. Okay, so if we just expand that a little bit, if we have something like this, the modulus of x plus 1 is equal to 9, how do we solve something like that? Well, there are two ways of doing it, really. What you can do is you can say x plus 1 is equal to 9, or x plus 1 is equal to minus 9. What's inside here could be 9. What's inside here could be minus 9. Well, let's just finish that off. That gives me x is equal to, subtract 1 from both sides, x is equal to 8, or x is equal to minus 10, subtract 1 from each side. So does that work if we check that? Well, if x is equal to 8, we get the modulus of 8 plus 1 equal to 9. Well, 8 plus 1 then is just equal to 9. So that gives me 9 is equal to 9, so that's correct. What about minus 10 here? Well, we've got minus 10 as our x, plus 1 is equal to 9. What does that give me? Well, minus 10 plus 1 is minus 9. Modulus of minus 9 is equal to 9, so 9 is equal to 9 again, so that's fine, that works. Now another way of doing this is to square both sides. So if we take the modulus of x plus 1 equal to 9. Now, what's inside here could be positive or negative. 9, if you like. Yeah, so x plus 1 can be positive or negative. However, if we square what's in here, well, then what we've got will be positive, but you've got to square the right hand side as well. So square the left hand side. So we can square the left hand side, and we get x squared plus 2x plus 1 is equal to 81. So that will give me x squared plus 2x minus 80, and that's equal to 0. So what you would need to do now is just factorize this here. So we would get 0 here, so we've got an x here and an x here. Well, 80 then, 80 is going to have, let's see, 1 times 80, that's not really going to work. Remember, we want a 2 in the middle. We've got 2 times 40, again, that's not going to work. 3 won't go in, so we've got 4 times 20, still won't work. We've got 5 times 130, 16. 5 6s, yep. Again, that still won't work. 6 won't work. 7 won't work. 8 might work. Let's see, we've got 8 times 10 I think will work. So there's a difference here of 2, and that's exactly what we want. So let's put the 10 here. Not the 2, it's going to be 8 in here. So we want a plus and a minus because this is minus, and we want the largest one to be plus. So let's put the plus here and the other one here. That will give me x is equal to minus 10 or 8. And they're the exact same solutions that we got up here. X is equal to 8 or x is equal to minus 10. And you can check those as well. I've done it already up there. So that's two ways of solving these two. You can square both sides, or you can just say x plus 1 is equal to plus 9, x plus 1 is equal to minus 9, and do it. Okay, now let's take that one again. We've got, and let's take it as a function this time. F of x is equal to the modulus of x plus 1. Now let's take another function. Let's take g of x is equal to, let's say, 2. And we'll deal with this in a few minutes. But how would you actually draw a function that looks like this? We know this one here is easy enough. This is just going to be y is equal to 2. This is just going to be a horizontal line going through the y-axis at 2. So, but what about this one here then? Well, what you've got to do here is, you can do this on your calculator. Your calculator will actually do this for you, or it should do. Most calculators will have this absolute symbol here. You'll see that somewhere, or you'll see the words ABS on your calculator. And that will allow you to put in these two symbols here, and you can use the function mode on your calculator to put your function in. But if you have to do it manually, you do it the normal way. You write down whatever the x is that you're going to use. You write down your function, which is x plus modulus of x plus 1. You write down y, and then finally we'll just list the points that we're going to use. So let's do a few. See what we end up with. Well, let's take an x as, we'll go for minus 4, we'll go for minus 2, we'll go for 0, we'll go for 2, and we'll go for 4. Okay, so let's take minus 4. Well, minus 4 plus 1 will be here. Minus 4 plus 1 is minus 3, and the absolute value of minus 3 is going to be plus 3. So our point is going to be minus 4, 3. Let's put in minus 2, so we got minus 2 plus 1. Minus 2 plus 1 is minus 1, and the absolute value of minus 1 is going to be plus 1. So we got minus 2 plus 1 here. Put in 0. Actually, you know what, I might put in an extra one here. Yeah, I'll do that in a second. We put in 0 plus 1, and that will give me 1 here, so that will give me 0 and 1. Let me just finish these two off first of all. So we got 2 plus 1, that'll give me 3, and the modulus of 3 is 3, so we've got 2, 3, and then finally we've got 4 plus 1, which is 5. The modulus of 5 is 5, so we've got 4, 5 here. I'm going to do one extra one here. I'll just do it in a different color here. In here, I'm going to put in a minus 1 here as well. There's a reason for that. So that'll give me minus 1 plus 1, and the modulus of that is just going to be 0. So that gives me minus 1, 0. Okay, so let's just draw this. So we've got we've got to do our x and y axis. Our x-axis is going to go from minus 4 to 4. So let's just draw that first of all. So we got minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, and 4. Our y-axis will come down here then, so through 0, almost. And our y's go from 0 up to 5, so let's do that. 1, 2, 3, 4, 5. Okay, so let's plot our points then, and we'll plot them in, let's plot them in blue. Okay, so we got minus 4, 3. Minus 4, 3 is going to be somewhere around here. Minus 2, 1 is going to be here. We have this minus 1, 0 here, and you'll see why I've done that now. 0, 1 is going to be here. 2, 3 is going to be here somewhere, and then 4, 5 is going to be here. Join all of these up, and you see what kind of graph we get. We get two straight lines. Well, it's supposed to be straight anyway, but you get the idea. We get this V-shaped here. I have it done a little bit better separately. I'll show you that now. So we have this V-shaped here, and you can see why I picked this point here, -1, because at -1 you've got the vertex of this V here. This is where it hits the x-axis, and you know our function was f of x is equal to the modulus of x plus 1, and the way of finding this particular point here is just to take the x plus 1, let it equal to 0. Remember, this is y here. You want y to be equal to 0. Don't worry about the modulus signs. And then you get x is equal to -1. At x is equal to -1, at x is equal to -1 here, the y will be 0. So you can just plot that point immediately or fairly quickly, and then you just need 2 or 3 points on either side of that in order to draw these straight lines. Remember, to draw a straight line you only need 2 points, but usually we do 3 just in case we make a mistake with one of them. So you can join up the 3 points, join up these 3 points. So you got 2 straight lines meeting at this point here. Okay, so it looks, oh, by the way, we had this other function as well that I mentioned. We had g of x equal to 2. So that's just, as I said, a horizontal line through 2 here. So that'll go through here like this. And the kind of question you can be asked is, you know, you can be asked to draw this function here, and you can be asked to draw this function here, and then hence show that the modulus of x plus 1 is equal to 2, or show, not show that it's equal to it, but find the values of x where the modulus of x plus 1 is equal to 2. So you would show these two on your graph, which I've just done, and then you would need to find the point of intersection of these two graphs. So you can be asked to find this point here and this point here graphically, so you just read the points off the graph. Looks like it's around -3 and 1 here, but I've just got it a little bit off here because I didn't draw it too accurately. But you will be asked to just confirm that algebraically. So algebraically you can do it the way I've done it up above. You can say x plus 1 is equal to 2, or x plus 1 is equal to -2, or square both sides, whichever you like. So here you get x equal to 1, and here you get x is equal to -3, and that's what it looked like on our graphs as well. So the way I've actually done it here a little bit better, I've drawn the graph using Geogebra here. So this is the f of x is equal to the modulus of x plus 1 between -5 and 5, and this horizontal line here is g of x is equal to 2. And you can see here the points of intersection are -3 and 1. X is equal to 1, x is equal to -3. We did that algebraically and found those 2 points. And here we can see graphically it done a lot more accurately than I did it, is -3 and 1. Okay, that is really it for absolute values at this stage.